Hello, my SS3 students. Sure, you're doing very well at home. My name is Mr. Seun Akinmolayan, your physics teacher at Sleek Angels International School. I'm glad to bring this revision class to you via this video, and I believe it's really going to refresh your memory. Alright, today we'll be looking at collision under the topic motion. Now, collision is talking about two bodies either moving in the same direction or moving in different direction that collide together, and then when that happens, they could either move separately or they move together. And so for collision we have two types. Basically, we have two types. We have the elastic collision and then the inelastic collision. The elastic collision talks about two bodies colliding with each other and then rebounds back after the collision. And then for inelastic collision, when the two bodies collide, they stick together and then they move together in the same direction. So today we'll be looking at some examples as a form of revision. Okay, so we have the first one here. A gun of mass 2.0 kilograms fires a bullet of mass 1.6 times 10 raised to power minus 2 kilograms due east. If the bullet leaves the nozzle of the gun with a velocity of 150 meters per second, what is the velocity of the gun? Now, in this question, what this question is talking about from what we have learned is the recoil of the gun, such that when the bullet goes out of the gun jerks back, and then that process is called the recoil of the gun. Alright, so let's solve this first question. Solution. Let the mass of the gun be mg, which is equal to 2.0 kilograms, and then let the mass of the bullet be mb, and that is 1.6 times 10 raised to power minus 2 kilograms. So if the velocity of the bullet equals 150 meters per second, then the velocity of the gun Vg equals question mark. That's what we're looking for. All right. Okay, from the law of conservation of momentum, momentum of the gun equals momentum of the bullet. Momentum of the gun equals momentum of the bullet. So for the gun we have mg vg, and then for the bullet we have mb vb. So if you substitute that, we have for the mass of the gun we have 2.0 times vg equals mass of the bullet we have 1.6 times 10 raised to power minus 2, then times the velocity of the bullet, 150 meters per second. Alright, if you make the velocity of the gun the subject of the equation, okay, if you make the velocity of the gun the subject of the equation, we have Vg equals 1.6 times 10 raised to power minus 2 times 150 all over 2. Okay, so the velocity of the gun equals 1.6 times 10 raised to power minus 2 times 150 all over 2. The velocity of the gun is Vg. Therefore, Vg equals 1.2 meters per second. Now the question says the bullet moves in the direction of the east. It moves towards east. So if the bullet moved towards the east, then what happens to the gun? As a matter of fact, the gun and the bullet move in different directions. So it therefore means that if the bullet moved towards the east, then the gun will move towards the west. So our final answer will now be the velocity of the gun equals 1.2 meters per second due west. Okay, so that's the velocity of the gun. Alright, we go to example 2. Alright, we go to example 2 right away. Example 2. An object of mass 40 kilograms moving with a velocity of 3 meters per second makes a head-on collision with another object of mass 10 kilograms moving with a velocity of 4 meters per second in the opposite direction. If both bodies stick together after collision, calculate their common velocity. If both bodies stick together after collision, calculate their common velocity. So we're going to list out our parameters. We have two bodies. Body 1 moving in a direction. We have the second body moving in opposite direction. And so this is before collision. Now, after collision has taken place, the two bodies got stuck together, and so they are moving together. Alright, so if this is M1 and then this is M2, so mass, so we call this mass of object 1 or body 1, M1 equals 40 kilograms. Then velocity of object 1, let's call that one U1, equals 3 meters per second. Mass of object M1, that is 40 kilograms. Velocity of object M1, that will be U1, equals 3 meters per second. Now for M2, the second object, M2 equals 10 kilograms. U2 equals 4 meters per second. So they are both joined together here. Everything will give you m1 plus m2. Then they have common velocity. So we have to calculate the common velocity. From the law of momentum, from the law of momentum, momentum before collision equals momentum after collision. So we have m1 u1 plus m2 u2, which will give m1 plus m2 all into bracket v, where v is the common velocity. m1 is the mass of the first object, u1 is the initial velocity of the first object, m2 is the mass of the second object, and u2 is the initial velocity of the second object. And then since they are together, they got stuck together and they're moving with common velocity, this type of collision is called inelastic collision. Inelastic collision. So we can substitute our values. M1, so we have 40 times u13 equals m2. Our m2 is 10 times, but we were told that the velocity of the second body happened to be in the opposite direction, which means it's going to be negative. So we have -4. So we have this plus this equals bracket 40 plus 10, then v, where v is the common velocity. So from here we have 120 minus 40 equals 50v. 10 plus 40 gives you 50 and then v. Alright, so from here we have 80 equals 50v. If you now make v the subject, so we have v at the subject of the equation, divide both sides by 50, so we have 80 over 50. Then v equals, if 0 cancels 0, you punch your calculator, you have 1.6 meter per second. So that's the common velocity that the two bodies moved with after the collision. Alright, so with this, I have an assignment for you based on these revision, so that you can as well practice and then forward it to me. Alright, so you have an assignment here in which you have to practice based on these examples we have solved, so that you can as well send it back to me. Alright, number 1. A body A of mass 2.0 kilograms moving with a speed 48.0 centimeter per second collides with another body B of mass 0.2 kilograms at rest. If the two bodies after impact move in the same direction and the speed of A is 2.00 centimeter per second, calculate the speed of B. Alright, the second question, a truck of mass 500 kilograms carrying a drum of mass 150 kilograms moves with a velocity of 50 km per hour. If the drum rolls down and moves in the direction of the vehicle with a velocity of 10 km per second, what will be the new speed of the vehicle? I hope that question is clear. So please just attempt the two questions and then forward your answer to my WhatsApp number on 08034796589, or you can send it to my email princeoluwashew91@gmail.com. Okay, I want to believe that these examples and this revision are refreshing your memories. So please keep reading at home while we wait for the school to resume. Extend my greetings to your parents. Take good care of yourself. Stay safe and stay healthy. Bye.